Okay, right, starting off differentiation. Just want to remind you, can you guys come around this side so you can see? So we're not under the, you can see what I'm doing, you're not hidden by that thing. Right, your basic differentiation, just to remind you, say we had 8x cubed plus 3x plus 4. To differentiate, power goes to the front, take one off, that becomes an x, and the x disappears, and that disappears. Okay, now I'm just going to tighten that up a wee bit, showing you some new techniques. And I want to sort of get you used to seeing it written a wee bit neater than that. The proper way for writing out differentiation, if you had y equals x to the m, power goes to the front, take one off. It's just tightening it up that wee tiny bit. Now what we're going to move on to today, the next wee bit, is brackets. He's going to show you a few different techniques. So say if you had y equals 3x plus 4 squared. If you were going to differentiate that previously, you'd have to square out the bracket. So square the first, square the last, and double the product. Okay? And then you go dy by dx, 18x plus 24. Happy enough with that wee one? Okay. The next way, what I'm going to show you now is a quick way of doing it. To differentiate a bracket, if I was ever to differentiate a bracket, what I would do, I'm going to write it out formally here. I would do my normal differentiation, bring the power to the front, and take one off. Okay, just your normal differentiation there. So, bring your power to the front, and take one off. But then what you have to do if you differentiate a bracket, you must multiply the bracket by its derivative. So f dash x is your derivative. So I'm going to take my bracket, the derivative of that, differentiate that, you get 3. Okay, so that's the new wee bit. So that becomes 6 times 3x add 4, which should be what I got before. So if you look there, 18x plus 24. Okay, so if you're doing a bracket, you always bring the power to the front, take one off, multiply it by the derivative. All good with that one? Now, brackets can sort of disguise themselves a wee bit. Say if you had this y equals the cube root of x squared plus 4x. If I was to differentiate that, write it as a bracket to the power of a third. Do your normal differentiation. So power goes to front, take one off, and multiply it by the derivative. Got that? It's fine to leave it like that. If you want to tidy it up a bit, minus means you're in the bottom row. So that's 1 over, that's 3, so right in the bottom. So it's going to be x squared plus 4x to the power 2/3. 2x add 4. It's just a tidying up bit here. It's a bit that sort of concerns me a wee bit. Let me move this thing forward now. Okay. So 2x add 4 in the top, and the bottom 3, the cube root of x squared plus 4x squared. If you're tempted to bring that x out, you know, sometimes you see that the x could come out. If you want to do that, just watch how you do it there. So it's 2x add 4, 3. If you're bringing the x out, make sure you bring the power with it. Okay? Which gives you x plus, oops daisies, 4 2/3. Okay? So, but I wouldn't bother bringing the power out of that. Got that wee one? Happy enough. Okay, that's brackets. I'm just going to have to work with the top half of these pages, because that thing's going to fall off if I don't. The other wee thing I'm going to show you here is upside down. And I would use this if I was given x equals, say, 6y squared plus 4x. We'll do okay in there. Now, if I differentiate that, I'm not making that too complicated at the minute for you. Now I put all the x's on one side, so bring that over, it becomes minus 4x. So it's minus 3x equals 6x squared. You want x equals, so x equals, just bringing that minus 3 over and divide, so it's minus 2y squared. Isn't that right so far? Yep. Then you'll go, because you have got x equals, you'll go dx by dy, as opposed to dy by dx. So you just differentiate that as it stands, so it's minus 4y, and then you turn the thing upside down. So dy by dx is 1 over minus 4y. Happy with that?
Yeah.
Okay. I very rarely use upside down. I just would use it if I had x equals like that. But I'll show you what I would do in that case. is a thing called implicit differentiation. Either of you two heard of that?
Nope.
Right. Implicit differentiation means you differentiate the x's as normal. You differentiate the y's as if they were an x, but you write dy by dx beside it. It's a bit weird, but you see what I mean by that. Say I was given this expression here, minus 3x equals 6y squared. I would write down differentiate with, I better write that out for you the first time, with respect to x. So if I differentiate that with respect to x, I get minus 3. Okay? If I differentiate this with respect to x, just do your normal differentiation. So it's 12y to the power 1. Because it's a y, you must write dy by dx beside it. Okay? That's the only difference. Now if you tidy that up, bring that across to the other side. And you can see you've got exactly the same thing as you have over there, minus a quarter over y. Happy enough with that?
Yeah.
So upside down if x equals, or implicit is the way I tend to do it all the time. I'm going to show you quite a complicated one here. Say if I had x cubed plus 4y plus x square root minus 3 equaled 5y squared. And I asked you to differentiate that. If you were trying to get that as y equals, you're going to have a problem because you've got y squared and you've got y's. Okay, it's really hard to get that y equals. If you're trying to get x equals, again, that's going to be a huge issue for you. So what you're going to do in that case, do your implicit differentiation. So if you write down differentiate with respect to x. So you'll differentiate the x's normally and leave them. You'll differentiate the y's normally, but you write dy by dx beside it. So here we go. Differentiating that, 3x squared. Differentiating that, 4, because it's a y, write dy by dx beside it. Differentiate that, that's x to the power of a half, so half x to the minus a half, that will disappear. Differentiate this, 10y dy by dx. Put all your dy by dx's on one side, so 3x squared plus a half x to the minus a half equals 10y dy by dx minus 4 dy by dx, and then all you have to do is just pull your dy by dx out of that. Really useful technique. Okay, and bring it over. So you've got your 3x squared plus a half x minus a half over 10y minus 4 equals dy by dx. All good?
Yeah.
Liking that? Okay, I'm going to just, could you, Jack, just hold up there, because I don't want to take a new page for this, but say if I had y equals 4x squared. Everybody knows dy by dx equals 8x there. I'm going to show you if I write it out this way. Differentiate with respect to y. This is where it all comes from, okay? It'd be better, wouldn't it? Differentiate with respect to x. So if I differentiate that, it becomes a 1. Because it's a y, you write dy by dx beside it. Differentiate that, 8x. That's why you write dy by dx, because you're basically doing implicit differentiation. Okay. How's that seem? Happy enough with that?
Yeah.
Okay, let me pause.